Alright, so the other day we started looking at right triangles and the Pythagorean Theorem, and today we're going to continue looking at the Pythagorean Theorem. So we need our toolkit out, and we're on page 71 in our toolkit. And our page looks like this one. We talked about the top portion of this toolkit entry already. So today we're going to continue the toolkit entry by talking about the bottom. Let's just refresh what the top told us. The top told us that if we have a right triangle and we know two of the side lengths of this right triangle, we can find the third. So say for instance we have 12 and 9 as the two legs of the triangle, and we're missing the third side, x. We would take 12 and square it and add it to the other leg, 9, and square it, and that would give us the third longest side of the triangle, x squared. 12 squared is 144, 9 squared is 81, and that would give us x squared. So then we would add 144 and 81, and that gives us 225. That would give us x squared. And we're talking about undoing this squared, and we use this square root symbol, and we would take the square root of 225. So let's talk about how we do that on the calculator. On the calculator, you would have to hit the second key, and then you would have to find the key that has the x squared on it, because the square root is above it. And when we do the square root of 225, we get 15. So the missing side of this triangle is 15. So let's take a look at the second part of this toolkit entry, the converse of the Pythagorean Theorem. The converse of the Pythagorean Theorem states that if the sum of the squares of the lengths of the two shorter sides of the triangle equals the square of the length of the longest side, then the triangle is a right triangle. For example, they give us two. They have, do the lengths 6, 9, and 11 form a triangle. So they took the two shorter sides, 6 and 9, and they squared both of those lengths to get 36 and 81. And then they added them to get 117. They then took the third side, the longest one, 11, and squared it, and that gave them 121. And then they compared 121 to 117. Those two quantities are not equal, so it does not form a right triangle. In the second example, they have the side lengths of 9, 40, and 41. And these lengths do form a right triangle because when you square 9, you get 81, and when you square 40, you get 1600. And when you square 41, you get 1681, and those two quantities are equal, therefore it forms a right triangle. So let's try one. Let's use the side lengths 10, 12, and 15 and see if they make a right triangle. So we take the two shorter sides, 10 squared plus 12 squared, and we compare it to the larger side squared. 10 squared is 100, plus 12 squared is 144. That's going to give us 244, and 15 squared gives us 225. So those are not equal. It is not a right triangle. However, we do know what type of triangle it is then, because we know that 244 is greater than 225. So we should be able to tell if it's acute or obtuse.